Today I'll be going over Chapter 1, Safety. This chapter is so important that I'm going to make this video where I'm reading you the chapter. It is of utmost importance that all students understand the safety hazards before they begin work. Chapter 1, Safety. Safety protocols for projects. As an engineer, when we're doing engineering projects, we often need to use various tools and equipment that can be potentially hazardous. In this section, we cover how to safely enjoy the projects by following simple safety procedures and guidelines. Always take care concerning the health and safety of yourself and of others. Be mindful of the safety of others by using warning signs for specific hazards. Maintain a clean work area. Use appropriate eye and skin protection when soldering, machining, or dealing with chemicals. In the lab, when you're doing your soldering, the primary way that you're going to protect yourself for soldering is that you'll be wearing safety goggles. There's no need to wear skin protection for soldering. You just need to wash your hands after you're done. When machining or using chemicals, you may need skin and eye protection. Okay, never directly look into a laser or at its reflection. So in the projects, you're going to be working with a laser level, and you're going to make sure that you aim it away from others when you're using it. For your optics project, I just mentioned that, point your laser away from other people and towards a wall. When conducting experiments with hazards or a potential hazard, before you begin the experiment, you should ask yourself, what are the hazards? What are the worst possible things that could go wrong? How will I deal with them if they do go wrong? And what are prudent practices, protected facilities, and equipment necessary to minimize the risk of exposure to the hazards? So as an example, two of the main project hazards that you're going to be encountering through the STEM clubs will be that you'll be working with high temperature soldering irons, and you may accidentally short circuit your project. So let's talk about the soldering irons in particular. So what are the hazards? Well, you're working with a high temperature tool, hotter than most ovens. What can go wrong? You may burn yourself. How will you deal with them if they do go wrong? So you should have a procedure in place where you're going to handle the soldering iron carefully, and you're also going to have to treat with cold water and ice and first aid if you do get a burn. And the prudent practices and protective equipment, well, you'll wear safety goggles to minimize the risk of getting hot solder splashed on your face or into your eye. Okay, so step number 9, or item number 9, do not be afraid to stop working or to ask a coworker or other student to stop their work if you see an unsafe condition. For example, if you see someone with loose paper near to a soldering iron, or if you see their hair not being tied back. If their explanation is unsatisfactory, please consult a counselor, lab assistant, or instructor immediately. It's important to wear the appropriate clothes to minimize the safety hazards. Due to various hazards, students need to tie their hair back. So this is to prevent hair from accidentally getting into machines or getting burnt with the soldering iron. So shown here on the left is a student who's wearing safety goggles and using a soldering stand to hold the part as she's working. And she's holding the soldering iron like a pencil. Okay, so tie the hair back, remove loose jewelry, wear long pants or a long skirt, a shirt with covered shoulders, and toe-covered shoes when working on a project or during a lab tour. Due to the increased risk of electric shock, you should never wear or never have bare feet in the lab at any time. If you have sandals or flip-flops, you'll need to change into regular shoes and socks before entering a lab area. For your STEM clubs, the soldering is going to be the largest hazard. So this section is extremely important. In addition to the above dress code mentioned, students must also wear safety goggles. Whenever soldering, the dress code is designed to reduce the possibility of severe burns resulting from the splashing or dripping of the hot liquefied solder metal into the face and eyes or onto exposed skin on your body. Although soldering itself is generally not a hazardous activity, there are a few things to keep in mind. The first and most obvious is that it involves high temperatures. Soldering irons are going to be 650 degrees Fahrenheit or higher. and will cause burns very quickly. Note that your oven at home, when you cook, is usually set to 350 or 425 degrees Fahrenheit. So pulling that dish out of the oven, it's very, very hot. You're going to use safety gloves to be, or pot holders to take it out of the oven. When working with the soldering iron, they have special grips that prevent the soldering iron from getting hot, at least the part that you're holding. The tip of the soldering iron is going to be at the 650 degrees Fahrenheit. So make sure to iron and to keep the cord away from high traffic areas. So you don't want others walking by, talking to you, stopping right next to you, possibly tripping over a cord while you're soldering. The solder itself, so that's the metal part, can drip. And so it makes sense to avoid soldering over an exposed body part, like you do not want to do this over your lap. Always work in a well-lit and well-ventilated area where you have enough space to lay out parts and to move around. So the solder will produce some fumes. Do not inhale the fumes. So in general, if you're working in a standard room and you have a window open or a door open, it's fine. You just want to make sure that you're not sticking your head directly above the soldering iron as it's creating these fumes. We will work with generally lead-free solder. Okay, so avoid soldering with your face directly above the joint because the fumes from the flux, so the flux is the special chemicals that they put in the solder so that it sticks well with the circuit elements. So the fumes from the flux and other coatings will irritate your respiratory tract and eyes. Most solders contain lead. The solders that we'll be providing you do not. So in general, you should make it a practice, whether it's lead containing or lead free, that you should avoid touching your face while working with the solder. And you should always wash your hands after you finish soldering, especially before eating. In the labs, there is to be no food, no drink, no application of makeup. Due to the increased risk of electrical shock and the fact that lab equipment is expensive to both calibrate and to repair, absolutely no drinking of beverages, consumption of any food of any kind, chewing gum, or applying makeup is allowed in the lab. Laboratory equipment. The lab equipment, especially the soldering iron, should be turned off when not in use for more than 5 to 10 minutes. So if you're going to work on something else while you're soldering and you're going to come back to the soldering iron, just make sure that you think about how long will it be on and by itself. If it's more than 5 or 10 minutes, then turn it off. It heats back up relatively quickly. At the end of the day, all equipment must be turned off before you leave. And do not take any equipment from the lab. The next section talks about power supplies. As you're building your circuits, you never want to plug your project into a wall outlet. The reason for this is there can be errors in what you're building. And even if you're considering using what's known as a DC adapter to reduce the voltage from 110 volts down to a safe level of 4 or 5 volts, if you make a mistake, there's no protection that's going to stop the current from flowing through your circuit and potentially causing circuit elements to burn. So always use a battery power supply instead. If for some reason you make a mistake with the battery power supply, at least the plastic will melt and then your battery circuit will get disconnected. So if your project happens to need to connect to a cell phone or computer, so let's say that you've really mastered the concepts from the STEM Club and you've built an advanced project as part of your robotics team or something, make sure you use only approved input and output ports. For example, connecting the USB port for the Arduino project or the audio jacks for the microphone headsets. Batteries will be the primary source for our power, yet they present several safety concerns. Number one, never plug in your batteries to your projects until you're completely done working. So a lot of times students will test out some parts of their circuit, which is fine, but you shouldn't be having your power connected to your circuit as you're adding components or as you're removing components. So wait till you're completely done. When you're doing some of the projects that involve soldering, you're going to have excess wire on the backside of the circuit board. If you don't cut the circuit or the backside excess wire, they have a tendency to short to each other. So make sure you cut this excess wire on the back of your circuit board and make sure that your circuit connections have all been checked. So if you're working as a team, have one of your other partners check your circuit to see that there are no short circuits. Also ask an instructor if possible. If you need to do additional work, so you find that there's something incorrect in your circuit or you want to add something, remove the batteries from the circuit. Batteries will get hot if there's a short circuit, or if you've accidentally plugged in a voltage to the output of a logic gate or connected the inputs of a transistor incorrectly. As I mentioned, the AA battery, even a single one, can melt from a short circuit. It puts out a lot of current. If your battery pack, while you're working on the project, gets hot or you smell something, so smelling is a good sign. If you smell something, it's a good sign that you've burnt out a resistor or other component. Or if your circuit doesn't work as you expect, immediately disconnect the batteries from the clip. So one safety point that I'll make is when you're testing out your circuit, it's a good idea to have one hand on the battery pack so you can feel instantly that as you've connected the circuit, whether there's something wrong and that you have a short circuit and something heating up. It's a much better idea than to plug in the battery and then just watch and see if something is burning. Always remove the batteries from the clips when the circuit is not in use, because the clip leads may accidentally short circuit when you're transporting your circuit from one place to another. And then for emergencies, contact your instructor, your lab assistants, or camp counselors, and call 911 if necessary. The remainder of Chapter 1 are topics that would apply for in-person. I will skip these topics until the students are in person at the University of Illinois campus to do this laboratory safety laboratory tours. Summarizing Chapter 1, safety is the responsibility not only of the instructor, but also of every student. Proper safety procedures start with a clear definition of the tasks to be performed and identification of the associated hazards. Appropriate safety protocols can then be implemented. For example, the task of soldering introduces the hazards of high temperature and fumes, which can be mitigated by following the dress code, wearing safety goggles, and working in a well-ventilated area. Accidents should be reported not only so that the person can receive treatment, but also so that lessons learned can be used to improve the safety procedures.